Okay, so hi, I'm Rocky Bernstein. I'm a longtime open source developer. So yesterday, if you heard Christine talk, she talked about these poor, pitiful, underpaid open source developers. Well, that's me. I'm Dilbert. I think somebody here yesterday talked about being in the summer code and how cool it was, and it is. He was a student. I was a mentor for the Python Software Foundation. The students get paid. The mentors don't. Has anybody found Waldo in here? No? OK. It's OK. So this talk is in two parts. The first part describes decompilation, and the second part demos that the decompilation in a debugger that I wrote. I wrote all of this stuff. So I write a lot of code. And I also make a lot of mistakes. And I make mistakes in finding my mistakes. And so when I do, I'd really like to know, where I am in the program, this is a slight exaggeration, but I feel like I'm trying to find Waldo in all this code there. And computers are really good at giving detailed information involving lots of calculation. But this is the one area that I think programming languages could do better and give more precise information. So let's look at a Python error. Okay. So here we have the file name bug. That's great, and it's on line 2. That's great, and it's in module, which just means it's in the main program. And here's the line of the error, and that's cool too. Okay, but it says integer division by 0. Well, it happens to be 0 here. And so which one of J or K was 0? And so here's some other examples. So I'm taking the prev of the prev, right? And if I get an error there, which prev are we? Are we talking about this prev or that prev? And even right. Okay, and by the way, I'm going to use this example and go into it in detail, so you'll actually, at the end of this, you'll see how we can know exactly which prev we're talking about. Okay. In this example, this is a list comprehension, right? And there's an awful lot going on here. And my point is, I don't think these things are all that uncommon. Maybe it's not this difficult, or maybe, but certainly in my experience, I get a lot of this. And so again, even if I know the index of I is 0, I still don't know which one of these lists you're talking about if I get an index error. And then the last example I think is the hardest and the most interesting, which is in Python and many dynamic languages, you can evaluate some code at runtime. And so here's an error message from an error in that. So here now it says file string. What the hell is string? Line 1, oh great, and name bad. And so now I'm back to my Waldo problem. Where in the world is bad in string? Okay. Okay. So how do we do better, right? Because this is not to bash Python. It's to offer a solution. But in order to do this, and this took me a while to realize. Well, okay. In order to do this, we need to look at how the computer sees the program versus how the programmer sees the program. So a programmer might write x plus y, and then but the C Python interpreter sees something like this. Okay, and in my notes I call this bytecode. It's actually called, this is Python 3.6 bytecode. Bytecode changes for every release often, and in 3.6. These are words. So let's understand this a little bit. 2 is a line number. 8 is the instruction address, but it's really an instruction offset from the beginning of the function or the module. Okay, so we have offset 8, 10, and 12, and this is what will change if you're before Python 3.6. This will be. If this is 8, then this will be 11, and that'll be 14, because instructions before that, the load name instruction before 3.6 was 3 bytes instead of 2. Okay. And so it might look like, okay, so we have an X here and we have an X there, right? There are three things here and there are three things there. Great. Maybe and it does kind of map one-to-one. Okay, here's the X. But wait a minute, this plus, that is actually this bottom thing, this binary add. So the order's been switched around. Okay, and so now let's compare this with human language translation, which you all probably are much better at than I am. So you may actually, had you written this code, you probably would have been much better at than I was. Because this is the part that took me a long time to realize, to understand. So it all looks very simple. But so I might say mango fragante. Did I get that close to right? Okay. And you might translate that to fragrant mango. And so I can figure that out. You know, I take the mango here, and I just switch the words around, and I change the spelling a little bit, and I'm kind of golden. Okay, so now let's look at another example. Entiendo. And you might translate that to I understand. Okay, so now here one word has been translated into two words. And now consider this one. So suppose I say templado, and I translate to not hot and not cold. Okay, so guys, tell me which part of templado is not hot, and which part of it is not cold, and not cold. Okay, and so we have a mismatch in concepts, right? There is no word in one and the other. However, fortunately for me and programmers, this kind of thing never happens in Python to bytecode translation because the two languages were designed to understand exactly the same kinds of things. Okay, so I'm going to do a side-by-side Python to bytecode translate. So first this. Okay, so right, this is very important. So right, so my goal is I want to understand this in greater detail than just that line kind of thing. And here's the thing is that you have all seen this problem before. Right, so when we do a side-by-side translation, okay, right, this line one is all, you know, when you take line one in its entirety, it's approximately like line one in Spanish, right? And line two here is approximately like that, maybe not exactly, okay? And you might think, you know, you might say, well, okay, right, some of the words are in the right positions. And this may sound funny that you'd be interested in this, but as a programmer, when I get an error and I get an offset and whatever, I'm saying, well, am I close to the beginning of the line or am I close to the end of the line? Because I'm trying to figure out where I am in that, okay? So in that particular situation, the stuff at the beginning, you know, is like the stuff at the beginning of the corresponding. But, you know, then we have something like this, right? And that kind of gums up the work. And that kind of thing, in fact, does happen a little bit in Python to bytecode. Okay, so now I'm going to do a side-by-side translation in Python. You know, x equals 1, y equals 2. You know, so now we have the two line numbers there, right? These two are associated with 2. And here, all of a sudden, we see, well, where's the equal sign? So I see an x here, and I see an x there. And I see 1 there, and I see 1 there, but there's no equal sign. And notice that the order got shifted around. X is at the beginning here, but it's at the end there. And there's a mathematical name for that called reverse Polish notation. And English adjective noun combinations are in reverse Polish notation. But Python bytecode in general is in reverse Polish. Okay, and so now if I want to get more detail, how do I break it down? Now, given that I've given this as a human language translation problem, again, you probably all know what the answer is. You break it down into its grammar. So here is a parse of an English sentence. And here's one translation you might, okay? And by the way, I actually had Mondongo last night here in Medellin. It was fantastic. But anyway, back to the point here is at the top, it's the same. We have a sentence and we have a subject and a predicate. Yeah, the subject is empty here. But again, if we go back, whoops. If you work in programs like I do, this is just, that's just an alternate representation of that, right? And it takes up less space. Okay, but at the top here again, you see subject, sentence, subject, predicate. So at the top, the levels all look the same. As you get down to the bottom, it may tend to not correspond so well. Right, I've also simplified things. People who are really picky might say, well, it's really a verb phrase, and that goes to a verb, and that goes to comma, and it's really object goes to a noun phrase, which then goes to a noun, and blah, blah, blah. And that just complicates it doesn't change the gist of what's going on. It just complicates your being able to understand the slide. Okay. So we're going to do this in Python bytecode. We're going to track how Python actually works, and this thing that I called a decompiler. So this was the example from the beginning. It parses into this. This is actually, Python versions 3 have something called an abstract syntax tree, and this is the abstract syntax tree parse of that. And blah, 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 blah. And it's abstract in the sense that these brackets don't appear anywhere down here. Okay, and when you write this, the Python will turn it into this. And then the next step is Python then turns it into this. It goes from that abstract syntax tree to this. And so I've written a deparser, which is like a parser. And it just looks at this, and it comes up with this. And this is a little bit less abstract in the sense, so here we have, was it 5 instructions? And so we have 5 instructions here. It's a little bit funky to look at because not all this, it doesn't run across the same line. These are at different levels. And actually, this one really should be like up there. But we'll see that those levels are very important when you're trying to understand what the meaning is. And the way I do this uses a little bit of standard compiler theory, but not the Dragon book. I mean, some of it uses half Dragon book, and some stuff in there that the Dragon book says you shouldn't use. Okay, and part of the reason we have this problem here is because there is a many-to-many mapping. It's not. I have a paper that goes into what the details are. I find it interesting, but the take on this is you can't, there may be an authoritative book on something, and then you want to change it a little bit, and a lot of what it has to say is not quite right. Okay. Okay, so now I want to show you how we go from this to reconstruct the text. Okay? I should also say one other thing here, down here. Here's a top and bottom comparison. So you'll see that, okay, so name is expr and index is expr. That's kind of not that important in that what's important is that name always goes down to one thing, and index always goes down to one, and so does expr. And these things are always, subscript can derive an index and a name and this. And I mean, it's not impossible. I can change my program so that these things match more. And I've done some of that. I could do more. Okay, but so now let's actually get text out of this. So what do we do? Oh, should have mentioned in the here. So some of these instructions have an operand, like prev. And the fact that these are both prev is just accidental, because remember I prev. But these could be different. And const has an operand, 0. But binary subscript doesn't. So now when I go to the text, the first thing I'm going to do is fill in those operand values, right? And these I have to leave out because they don't. There is no operand. And so now the next step we do is anytime there's an expr, we just copy the value of its child on up. And remember I said expr just always has one child. Okay, so that's pretty simple. Do that. I didn't fill in this one here because we haven't come to the subscript rule yet. But you can probably guess what the subscript rule is. You take the left thing here, you put brackets around the next, the second child, and you lose or drop off the last thing. And same thing and then same thing you do there. So I do that here, and right, left thing, brackets around the second thing, lose the last thing. Left thing, brackets around the thing, the child below, lose subscript. Okay, now I hope you'll all say, oh yeah, it's easy to see how I can tell. If I'm stopped at this instruction, right? Where am I? Well, I just go to the parent, and there's the text that's associated with it. And in display form, it comes out like this. So I'm at instruction 12 and binary subscript. So maybe I left a little bit out. Whenever you're running a program, you're always at a particular instruction. And that's what we're going to use to tell us exactly where we were in the program. So the process is we're at an instruction, we deparse this, we create a parse tree for it, and we use that mechanism of filling in text information, and that will tell me where I am in the program. And so if I happen to be at offset 14, right, I just go to the parent there, and that's everything. So that's this. And I'll point out, okay, so if you are at line 8, if you're at line 8, if you're at line 6, offset 6, it would be the first prev. If you're at offset 8, you'd be the second prev. If you're at const, you'd be at the 0. And we just went over those two. And so you have successfully completed Rocky's course on Decompilation 101. The rest of how am I doing for time? What is it? 22 minutes. Great. I think I'm about on time. So the rest of the talk, and so now's the time if you want to leave because this bores you to tears. I won't take any offense. The second part are a bunch of videos, and so those are pretty well timed, showing how I use this in a particular or two particular debuggers that I've written. So let's get to that. Okay, so I've written, one of the debuggers for Python 2 is called Japan 2. It has command completion, so you'll see once I get into it, I can type HE. And this first thing I'm just showing off help. So HE tab. And then that part right there really looks like what you would get if you were in GDB. And so this follows the GDB commands. Like in PDB, you can do help star. It's probably not clear, but if this were a skinnier display, all of this adjusts. You'll notice that this is in restructured text, and I've written a terminal formatter so that it shows on that. But again, I was showing the deparse command, and so there's pretty extensive information here. If you, this is also available from Read the Docs as an entire manual. But I just wanted to show that everything in here you can get the entire help from inside the debugger, and it's pretty extensive. The thing that we're going to be using is this. Of course, the option that we're going to be using a lot here is parent, or -p. Okay, so now let's get to work, but being Rocky, I ramble on a little bit of this too. There's a little bit of bullshit here. Oops. So now I'm going to actually start to use that deparse command. I'm going to use a list comprehension example. And notice I said which one of the places do I have an error. So I run my program there. There I get my index error. And so there are many ways you could do this, but I'm going to just run this inside the compiler to show off the compiler. Notice that there is some sort of syntax highlighting because I'm using pigments. So I'm using pigments to highlight this, and because I'm using pigments, I have access to all the pigment styles. So just for fun, I'm going to change it to a different style. And And those are the style names that happen to be loaded, but they come with pigments. Use that style, and you'll see that it changed the style a little bit. You can set that in a profile. Okay, so here's my error with the exception, and this was the payoff. Okay, so you see that, that's where I am, and I give you the parent context as well. So now I'm going to do it 2 more times with just different error locations. Blah blah blah. And so there's another. Okay, so what I'm showing is that this is instruction 56. That's where you are, but it's contained in basically the same parent as the previous one, and one more place. P. And so you see that the context even changed, or the parent changed in this third location. Wonderful. And now I'm going to show the one that's most difficult for any debugger. This is debugging code that's created at runtime. Okay? And those of you who use PyCharm or some other debugger, I'm curious to see how well your debugger does on this, because I have not come. If it does very well, let me know, because I'd be really interested in how it does it. Okay. So I've been yabbering here. So I'm taking. Let me see if I can stop this for a little bit. Okay. So the first thing you will get from the Python community is you shouldn't do that. You shouldn't create code at runtime. But except for in this conference where people are talking about machine learning, wow, that's the kind of thing that's done a lot, especially in AI. But what I'm showing here is I'm using name tuple. Okay, I'm going to give an example using name tuple. That's in the standard Python library. The name tuple, in fact, uses exec to do its stuff. So instead of giving me attitude, why don't you just solve the problem? Okay, and so I'm going to show you how to solve the problem. And this program is right from the tutorial of name tuple. It's creating a point. That's the class name. Has fields x and y. So I'm now creating a point with 1, 2, and then I'm going to print that. Okay, and so, and I'm doing this with PDB. But I don't think I don't think the results would significantly change if you were using IPDB or PUDB. I don't know that much about PyCharm. Oops. Continue here. Getting dizzy. And so the way I'm going to step into point is I'm going to set a breakpoint at 3 and then step. Maybe not the most elegant way. But now we see string. The wonderful string at line 8, whatever that means. And when I try to list the program, sorry, Charlie. Did I continue? Is it continuing? Yeah, it is. Okay. Thank you, Rocky, for highlighting that. And now I'm at line 10. Very, very fascinating. List still, list will give the same thing. Now I'm back in here's the print. I'm back in the program. And now I'm in repr, which is, and I actually get the same thing in repr. Okay, so now I'm going to use the Python 3 version of this, which is called Japan3K. It actually did detect that there was a black background, and it said it like that, but I don't like that. Maybe that's a bug. So I'm going to use pigments to change the style, blah, blah, blah. Again, you can set that in a profile. And so this command is a little bit different. It's not GDB. It's the same as break 3, continue. Since I do that a lot, I just threw that in. That is saying that I'm at offset 31 in module. And there we go. So I did a step there. And what you should see here, is it realized that there was no code. So it created this temporary file and showed me the appropriate line from the temporary file. Right, and that stuff there, it kind of doesn't work, but it's saying that line 1 of this file was what it thinks is line 14 of the original. right? Because we had line numbers in the original. I translated this into my thing, and the line numbers may mismatch. And so now that I can actually see what's there, I can ask interesting questions like, you know, what's x and y, okay? Can I stop that? Oh, well. I don't know. Basically, all I'm showing, in addition to decompiling, I'm using the DEPARSE to show you which part of this thing that I'm at. And if I can stop that. Did that stop? No. You can actually get more information. You know, so when the line is big like that, I've evaluated everything on the line. When the line is teeny, all the stuff that's not under the line hasn't been evaluated. So we had parameters and stuff like that, and those were not evaluated. So, but again, this is all online. You can go, you know, play with this all that you want. Blah, 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 blah. And that's the end of that. Right, so do I see anything here? Well, okay. Wrong button, but we'll just go with it. So now I'm going to show you something that's a slight variation of the last example, which again, I don't think you can do, which, well, I'd be interested if you could do this in PyCharm. And if you can do it in PyCharm, they're probably using my code because I had a similar experience in the Ruby, on the Ruby side. I gave a talk on this, and then and PyCharm did it, and how they were doing it is they were using this. So there is no source code. Whoops. There is no source code. And so boom. So here's some bytecode that I happen to have around. I'm going to use a disassembler, or my disassembler, but this header option gives me the metadata for that. It doesn't disassemble it, it just gives me the metadata for that bytecode. And so what you see here is it's 3.6 bytecode, and when the file was compiled, it was told that the file name was exec, which is really not that helpful. I happen to be running Python 3.6, good, so that means I can run that bytecode. And so that's what I'm going to be doing. I'm just going to run the Python, and it looks like it's fibbed, or it looks like it's fibbed. It works for 3, 4, and 5. And so now I'm going to do something devious, or not devious. I'm just going to, I can run it. Can I debug it? Okay, so I'm going to do Python -m pdb, that, 2. And this line here, source string cannot contain null bytes. It's thinking that this is source code. And it's so bollocksed that when I run quit, I can't quit. You can't hit, I couldn't hit Control D. The best I could do was stop it and then just kill it. And that works. Okay? So PDB gets, not only does it not work, it gets into a kind of funky state once you try to do that. So now this happens to be, this is obscuring the bottom line, but this actually happens to be an Emacs session. And I wrote another front end to not just this debugger, but all PDB, IPDB, bash, GDB. Okay, and can I stop that now? Okay, and so this here looks familiar, doesn't it? That came from the assembler, right? And okay, so let's just continue. Whoops. Blah 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 blah. Let me just finish this. What I'm showing here, so you see a green arrow there, and you see this green thing there, and now the thing before it was yellow and then brown. So these are the last 3 stopping points. This front end actually stores, it shows 3, but it stores all of the stopping points that you've ever stopped at. Stepping into this, I'm setting a display expression just to help me understand what's going on. And what I'm going to be showing is I'm going to go into the caller of this, and that's where I am now. And you'll see that I was in the first branch of the call, not the second, right? So it doesn't happen to be where I'm stopped. This also shows me in the call stack where I was. And so I'm just running this again, and then I'll get to the second branch, and you'll see that, and that's the end of that demo. And I'm sorry, this is obscured. Deparse. You see, now I'm in the second branch. The last thing I kind of show off is that the kind of thing that you'd kind of expect in this, that you can highlight in the source code some sort of something, and you can hit E, and you can get a val, and down here it'll say true. Oh, there it is. There it says true, and that's it. Okay, so blah, 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 blah. So what's that? So I've actually done this now for Python and Perl. Perl is easier because it has a tree evaluation. But this is a really general method. And what this is, just to show you, even if you don't understand, I've done some of this for Emacs Lisp as well. What this is just to show you is that even if you don't understand this all looks and works exactly the same way as all the other stuff did. And so now we get down to links. OK, so the decompiler is this thing. And it's very, very popular based on questions amongst reversed engineers. It uses this library xdis. We saw some of that with the disassemble minus header. This is the debugger, the Python 3 debugger. This is the Python 2. All these are available in PyPy. I thought, this is the read the docs, but there's a read the docs for this one as well. The Emacs interface to this is called Real Good. I hope you get interested. I hope you do other programming languages. I could use lots of help. And I just hope that even if JetBrains steals this like they sell other stuff, that's great. It's free. You can't steal from when the cost is nothing. So this is a paper that describes how it's like the Dragon Book and how it's not like the Dragon Book, and some of the funky stuff there. And that's me. And muchas gracias. Go easy on me. I'm like a prize fighter. I can give it, but I can't take it.
Good day, and thanks for the talks. This topic is very interesting because real identified errors is it's difficult when message is not clear, but when you use the utility, you need to navigate through the error message, and it's not an easy way to identify in one step the error. It's an abbreviation way to see them. It's not clear, the question. You navigate the error message.
Yeah.
Yeah. But when you use either IDA, you see one error message in the point. This is not similar.
Okay. He asks if there is an easy way or any single step that you can do to navigate through in a specific way where error message is generated.
So
that debugging process. If there is
so often what I do is I set a breakpoint, where I hit an error, and now I'm in this debugger. What I haven't done and should do is write something for the standard traceback. There's a standard traceback library, right? I could write the same thing and have this additional stuff in there. And that's very, very simple to do. I was hoping that somebody would volunteer to do it. But those are the two things that I can think of, is set a breakpoint close to, I do that all the time, set a breakpoint close to where I'm having problems. And now I have access to this thing, and I have a lot of granularity. Does that answer your question? Okay.
Thank you.
Thank you for your presentation. My question is, I was expecting that probably the PDB utility is the official utility for doing debugging. So my question is, do we need to use any specific debugger for any specific task, like, I don't know, web development, or try to run a script, or can we handle every of those problems with the PDB? That's enough.
So I showed something not PDB.
Yeah, exactly.
Okay, and if you know PDB very well, you'll see that they've hacked it for PyTrace, right? PyTrace has a special. So, and I've had to hack it for PyTrace as well. But I don't know how to answer. I don't know how to answer the question.
So probably there is no specific case for using another debugger. You can handle every kind of situation with the one that you mentioned.
This is not a debugger talk. So difficult cases are things like celery and
Exactly.
right? These things. So remote debugging is difficult, but there is remote debugging support in the Tropan debuggers. It might not be as great. So I had a distinct disadvantage in that people have hacked PDB for remote debugging. People have hacked PDB, so it adds color. That's why what IPDB is really based on PDB. Okay, in truth, if you use this, I've started making this work on celery, but I didn't need celery anymore, so I stopped working on that. So there are in debugging, it's. That's a whole different story and a whole different topic.
It's the same like linters. You can use any linter that you want. You can use any debugger that you want.
Well, no, if you're using celery, it's difficult. You have to use the hacked version of PDB for celery. And
hi, do you ever use any type theory approach in debugger?
do I have any what?
Type theory approach.
Type theory approach?
Yeah, type theory. When you present the error types, when you are looking the exact error is like working a constructive logic. So
Okay. So this is not a complete solution, but if you wanted to do that, you would have to, right? Supposing I wanted to, so that it is true that the error message that I gave just told you where I was, but it didn't tell me what I was, what the value of I was and what the value of the list was. But this would be a prerequisite for being able to do that. Without this, you wouldn't know whether it was A, E, D to even start investigating.
okay.
Okay, this was the limit of my ability, and if more people get involved, I think we could solve the other stuff too.
Okay, thanks.
Just thought, looking at the examples you've shown, that this tool might be really useful, but the pieces of code that you've used your debugger to test your debugger seems like really convoluted, complex statements that I'm not sure if. Yeah, like the list comprehension one. That's like.
No. That's an extreme, but
Yeah.
you use list comprehensions, right?
Yeah, definitely.
And you use list comprehensions with lists that you index, so that do this in something if something sub I, right? So you have that confusion there. This was extreme. I accept that. But I didn't write this because I just was interested in doing some abstruse kind of thing. I had these real problems, like I tried to debug into name tuple. Sorry, you're out of luck. I didn't.
Yeah.
Are you saying that example that I showed for name tuple? That comes from the tutorial.
Yeah. Totally.
Okay.
I was actually going to ask like real life examples of where this could be useful. And that's
How about the tutorial for name tuple if I really want to understand what's going on with name tuple? Okay. Thank you all.
Thank you.
This is good.